at a series of questions having to do with series convergence. And specifically in these examples, I want to show you how the comparison test works and also possibly the limit comparison test if I have time. So the idea is that if you have a series with terms that are less than or equal to the terms of a series that converges, that series will also be convergent. If you have a series with terms that are greater than or equal to the terms in a series that diverges, that series will also diverge, all right? So if we look at this first example here, 1 over n to the fourth plus 2, notice that this looks a whole lot like the series 1 over n to the fourth, okay? And these are referred to as p series. P is the exponent value. And so I can compare it to something that looks real close to that, 1 over n to the fourth, okay? And if you think about the terms of 1 over n to the fourth, 1 over 1 to the fourth would be 1. 1 over 2 to the fourth would be equal to 1/16. 1 over 3 to the fourth would be equal to 1/81st, and so on. And the key here is that 1 over n to the fourth is a p series with a p-value greater than 1. This is going to be a convergent series, okay? But notice, the denominator of the series that we're comparing to has that plus 2, okay? If you think about it, a fraction that has a larger denominator is actually smaller. So for example, if I have 1/3 and I add 2 to the denominator, I get 1/5. 1/5 would be smaller than 1/3, for example. So look at this. If we compare the first two values, 1/3 is smaller than 1. Okay, the next two values, 1/18th is smaller than 1/16th. Okay, 1/83rd is smaller than 1/81st. Okay, and this is always going to continue. So what we have here is a series 1 over n to the fourth plus 2 that has terms that are less than or equal to the terms of a convergent series. And as a result, this series is also convergent. Okay, that's the big idea there. Now let's take a look at the second example here. The second example, looking at this one down here, it's 1 over n minus 3. Okay, I'm going to compare to 1 over n. Okay, 1 over n is the harmonic. Okay, now this one's starting out, if you notice here, it starts out at 4. And the reason starting out at 4, if it starts out at 3, we could end up with a 0 in the denominator, so it's got to start a little bit later. But 1 over n starting out at 4, so that would be 1/4 plus 1/5 plus a sixth, and so on. Notice because I'm subtracting 3 in this fraction up here, the denominators are smaller. Fractions with smaller denominators are actually bigger. So for example, 1/2 is bigger than 1/5, for example. So down here we have 1 over n. And let's see here if I can get this back. Okay, we have 1 over n, and that is a divergent harmonic series. Okay, these terms are all greater. 1 is bigger than a fourth, 1/2 is greater than a fifth, 1/3 is greater than a sixth. I have a series in which all of the terms are greater than or equal to terms of a series that diverges. Okay, so by the comparison test, sometimes called the direct comparison test, this series will also diverge. Okay, in a minute, in a separate video, I'm going to show you a couple of examples of the limit comparison test, which is a little bit more complicated, slightly different, but definitely linked. So we'll look at that coming up next.